Now in the previous video I was discussing about for AP and GP. Now if a given sequence is not in AP and GP, then what I will do? Because for AP and GP, what I will do, I will find the sum of the terms, then I will find out limit n tends to infinity, what value does it give. Now if it gives a finite value, it is convergent. If it gives an infinite value, it is divergent. So this is for when the terms are AP or GP. So now we will be discussing when my term is not AP or GP, then what happens. So for this condition, what I will do is, we have two conditions for this one. So the first condition is, we will write the nth term. We will find the nth term. Okay. The first step is, we'll find the nth term of the given sequence. So an of the sequence. This is my first step. The next step will be to check whether to find this thing, limit n tends to infinity, an is equal to how much. The next step will be to check this thing. Now, if the value of this thing is 0, if the value of this thing is 0, then we can say that for convergence, the first step is valid. So if this one is equal to 0, then we can say that it is the first step of convergence. First step of convergence. To prove convergence, this is the first step. If it 0 comes, if it does not become 0, then we can say it's not convergent at all. Okay, so this one has to be 0. Why do you mean by this thing? What do you mean by this thing? Why it has to be 0? The fact is that when I add some terms, 1 plus 2 plus 3 plus 4 plus 5 plus dot dot dot. Now you see here, each and every term is increasing. Now if I have increasing terms like this, obviously if you add increasing terms like this to infinite number of terms, we can directly say that the sum will be divergent, right? But if we have certain series 48 plus 47 plus 46 plus 45, now this type of series is what? Here it is decreasing. Now decreasing means what? The sum will be less. The sum will be less. So there will be some term that is 0. So it will decrease to 0. So here we are proving that if I am going towards infinite number of terms, and if the last term is 0, if my terms are decreasing, then we can say that the sum is convergent. The sum is convergent. That's the first step of convergent. Because here it is decreasing. Now when it is decreasing, it means that the sum will be convergent. But if it's increasing, the sum will be infinite, so it's divergent. Clear? So that's my first step to check convergence of a series. Now the next step. The second step goes like, let me discuss, it will be the ratios test. Now this step will finalize and will tell you that whether the given series is convergent or divergent. So for ratio test, what we are going to do? So for ratio test, we will find out limit n tends to infinity, an plus 1 divided by an. We'll find out this one. Now what is an plus 1? An plus 1 is nothing but the next term to an. If I say a1, the next term to a1 is what? A2. So just like an, the next term is an plus 1. So n plus 1th term. So if the value of this thing is less than 1, then we can say that the sequence is convergent. Sequence is convergent. Now if the value is not less than 1, is greater than 1 or equal to 1, we can say that it is divergent. So limit n tends to infinity, an plus 1 divided by an is greater than 1, then we can say it to be greater than or equal to 1, divergent. So that's how we prove the sequence whose sum we cannot find, which is not an AP or a GP. So that's how we prove whether the sequence is convergent or divergent. So let me just discuss one of the questions in here. So here we have 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus dot dot dot. So this is my sequence. Now if you check carefully, this is neither AP neither GP. Okay, so since it is neither AP neither GP, so we cannot find the sum. So now since we cannot find the sum, we have to look for the second method. The second method was what? To find out the nth term. So how to find nth term? So an will be equal to what? Now if you look at the series carefully, this one I can write it as 1 by 1. Now for each and every term, it is what? There is a 1 in the numerator. 1 divided by something is that. Now here we have the first term is what? 1 by 1. The second term is what? 1 by 2. The third term is what? 1 by 3. The fourth term is what? 1 by 4. So like this way, the nth term will be what? 1 by n. So my an is 1 by n. So this is what we have an as 1 by n. Now my next step was to find the limit n tends to infinity an. So how much is this coming? Limit n tends to infinity 1 by n is equal to, now you see 1 by n. So if I have 1 by infinity, so 1 by very big number gives you what? A very small number. So it means that limit n tends to infinity 1 by n will go towards 0. Very small. So it's 0. So we see that first condition is satisfied. So I can go to the next step, that is ratio test. So first thing before ratio test, we need to find an plus 1. So what is an plus 1? If an is 1 by n, so an plus 1 will be 1 by n plus 1. So this is what we have, n plus 1. So now we will do by ratio test. By ratio test, what we are going to do? We have to find limit n tends to infinity an plus 1 divided by an. That is what we have. So let's put the values. Limit n tends to infinity, an plus 1 is what? 1 divided by n plus 1 divided by n is what? 1 by n. So what we have? Limit n tends to infinity, this n goes up, n divided by n plus 1. Okay, now this one how can we solve? I already told you a limit problem. Whenever n tends to infinity, you divide both numerator and denominator by the highest power. So here the highest power is what? N only. So I will divide n by n divided by n plus 1 by n. So what we are getting? Limit n tends to infinity, this one goes, we have 1 divided by, in the downside we have 1 by n if I separate. So this 1 by n becomes 0 if I put n as infinity. So we have 1 divided by 1 plus 0. So the answer is coming 1. Now since the ratio test value gives us 1, so we can say that the sequence is divergent. The sequence is not convergent, or we can say as divergent. So that's how we get not convergent. It's not convergent because by ratio test the value is coming equal to 1. So this is how we do. Okay, let me do another question. So here we have question number 15. So what is in here is 1 plus root 2 3 by 4, then plus root 3 3 by 4 whole square plus dot dot dot. Now again, if you check carefully, this one is neither AP nor GP. So again we have to find nth term. Now how to find nth term? Now if you look at carefully, the first term is 1, the second term is root 2 3 by 4, the third term is what? Root 3 3 by 4 whole square, the fourth term will be what? Root 4 3 by 4 whole cube. That's how we get. So basically the second term root 2 is there, third term root 3 is there, so obviously nth term root n will be there, right? Then you see that the power of 3 by 4 is decreasing. For the second term the power of 3 by 4 is what? 1. For the third term the power of 3 by 4 is what? 2. And for the fourth term the power of 3 by 4 is 3. So obviously for nth term the power of 3 by 4 will be n minus 1. So this is my an. Now we have to find the limit. So we have to do limit n tends to infinity an. So that is equal to limit n tends to infinity root n 3 by 4 to the power n minus 1. Now you see again 3 by 4 is what? Less than 1. And in the head of 3 by 4, the power of 3 by 4 is what? infinity minus 1, and infinity minus 1 is infinity only. So basically we have what? Something less than 1 to the power infinity, and I told you what? The value of this thing will be 0, because always remember something, whenever we have something less than 1, 0.5 less than 1 to the power infinity, the value of this thing will be 0. Always remember this one. So now the next step will be to do the ratio test. So for ratio test we have to find an plus 1. So an plus 1 will be what? Just do one thing. In an, wherever you have written n, just put n plus 1. So I will write root over of n plus 1. In place of n I am writing n plus 1. Then 3 by 4 to the power, in place of n I am writing n plus 1 minus 1. So this one goes. We have root over of n plus 1, 3 by 4 to the power n. This is what we have. Then what I will do is by ratio test. So by ratio test, what you got? Limit n tends to infinity, a by n plus 1 divided by an is equal to limit n tends to infinity. An plus 1 is what? Root over of n plus 1, 3 by 4 to the power n divided by root over of n, 3 by 4 to the power n minus 1. This is what we have. Now we know one thing, 3 by to the power 5, if I have like this 3 by to the power 5 and 3 by to the power 4, so we can cut these two and we have what? 3 by 4 in the numerator. So basically what happens, this 3 by 4, this 3 by 4 is same. So if the base is same, the powers, and we are dividing, so the powers will subtract. So we can write this one as limit n tends to infinity. Now we can combine these two and we can write n plus 1 by n, because both are square root, and since it's divide, the power will subtract n minus 1. So this is what we have. So after this, what do we get? Limit n tends to infinity. Now can I write this one as root over of, if I separate n by n plus 1 by n, so we get 1 plus 1 by n, and this becomes 3 by 4. Now look at here, this n, if you remove the bracket, n minus n, that goes out, cancel, and minus minus is plus 1, so we get 3 by 4. Now put n as infinity, so 1 by n will become what? 0. So we have what? Root over of 1 into 3 by 4. So basically we have 3 by 4, and 3 by 4 is what? Less than 1. So by doing ratio test we are getting this value as less than 1. So the sequence is convergent. It's convergent. So this is how we prove the sequence to be convergent or divergent if the sequence is neither AP nor GP.